When you see a similar problem to solids that are similar, you go immediately to a proportion. On one side of the proportion, find two corresponding parts, like this slant height, which corresponds to this slant height. We'll put the larger slant height on top and the smaller slant height on bottom. 9 on top and 6 on the bottom. Then on the other side, we'll put the ratio of this other fact they tell us and what they're asking for. So these should be the same things. We've got the surface area of pyramid A, and they want to know the surface area of pyramid B. So since pyramid A's slant height 9 went on top, we'll put its surface area on top. And for the bottom, it's pyramid B's surface area, which is what we're finding. Let's call it S. Now this proportion is not yet true because of the units. We don't have to write them, but what are the units for 132 as a surface area? It's square centimeters. But on this side, the ratio of 9 to 6 is centimeters to centimeters. This proportion is not true until these units match. So we need to square the left side so that we have square centimeters on the left, just as we do on the right. So we'll square these values on the left, and now we have square centimeters on the left and square centimeters on the right. In other words, this green ratio of surface areas was two-dimensional. We needed the ratio on the left to also be two-dimensional, and now it is. Now, oftentimes you'll see people simplifying 9/6 because it does reduce to 3/2. And then we could rewrite this proportion if we wanted to using 3/2. That's still one-dimensional, so we still need to square it so that we have square centimeters on the left to match the square centimeters on the right. Anyway, at this point, now we cross multiply and we can find S, the surface area of pyramid B. 9 squared, or 81, times S. And 132 times 36 is 4752. And then dividing both sides by 81 leaves us with the surface area S is 58 2/3. We get the same answer if we had used the reduced fraction. So there you have it.